This is going to be a introduction again or a review of unit. I spelled that wrong, but your paper will be correct. Unit rate of change, slope from a data table. Excuse me. So what we need to do, as we've talked about with the Rose, Tyler, and the doctor, we are going to figure out how are all the x's changing and how do all the y's change. And when I say change is how do you go from 0 to 1? You add 1. 1 to 2 plus 1. 2 to 3, we added 1 also. Then I'll do the same thing for the y, the output to go from 5 to 9. You added 4. 9 to 13, you add 4. 13 to 17, you add 4. To determine the rate of change, what's the unit rate? If we made up a story problem and this is the situation, we are looking for the change in y's, right here, the outputs, over the change in x's. So how do these change in relationship to each other? When I look at this, I can see my y's, my outputs are changing constantly by a +4, while my x's are changing by a +1. So they have a rate of change of 4. Now, if we were to graph this, think about this just a minute, we would have a +4 as our rate of change. Thinking back to slope dude, if we put it on a graph and we had a +4 rate of change, our line would be headed uphill. For slope dude, it would be a puff, puff, positive. This number, the rate of change, is telling us the direction and the steepness of a line. Let's look at the one to the right. First, I'm curious, how are all of our x's changing? So to go from 0 to 1, we add 1. To go from 1 to 2, we add 1. To go from 2 to 3, we add 1. But our y's are doing something a little different. How do you go from a -10 to a -15? Are you adding or are you subtracting? We would actually subtract 5. To go from -15 to -20, you subtract 5 again. And -20 to -25, subtract again. So it is the change in the y's, the outputs, -5, over the change in our inputs, the x's, +1. If I simplify that, my unit rate is -5. If I wanted to create a story problem with this, someone is spending $5 a week, losing 5 pounds a week, something like that. It is negative. So when we start graphing, we know that this change is negative. So that would be a nice negative on our graph. This number will tell us what direction will the line go. In a story situation, what is happening? Something is decreasing. Savings account, pounds, things like that. Next, we have inputs again. Oh, I changed it up. How do we go from 2 to 4? We add 2, we add 2, we add 2. How do we go on our outputs from 11 to 15? We would add 4, 15 to 19 means we must have added another 4, and we're going to add another 4. Okay, it is the change in the y's plus 4 over the change in the x's, so we can get our unit rate. If this was weeks, for example, and this was money saved, we would end up saying this person saved $2 per week. If we were to graph this, it would be a positive line because our rate of change is positive. The y's are increasing as the x's increase. All right, for the next one. Oh, let's check this out. Let's just pretend this is days and candy eaten. How much candy did these people eat every day? Can't really have negative days unless we're talking about something that happened last week, but that's okay. So a week ago, here we go, -7 to -4. How do we do that? We would add 3. To go -4 to -1, we would have to add 3. -1 to 2 is a +3. Let's talk about the kind of candy and how much this person is eating. On the first day, he was eating +9. And then from here to here, another +9. Here to here, +9. So how many pieces of candy per day, or how many pieces of candy per day did he get? I would have 9 over 3. So each day he would increase his candy by 3 pieces per day. Maybe he's saving candy. He's stealing other people's Halloween candy because it's increasing. He's really not eating it. We should talk about candy stolen. Notice on the tables I've done so far, I keep having all of our x's change at a constant rate. We had +1, we went to +2, we went to +3. Now we're going to kick it up a notch, so to say. To go from -3 to 0, I have to add 3. To go from 0 to 2, oh, that's not +3, that's +2. To go from 2 to 5, 2 to 7, we'd have to add 5. Now we're going to see how these are changing to go from 40 to 31. I see the numbers are decreasing, so I know I need to subtract. 40 minus 31 is 9. Again, we're going from 31 to 25, so I can see it's decreasing, so we need to subtract, and I would subtract 6. 25 to 10, we are subtracting, and I would have to subtract 15. Oh, all the other ones, because they were constantly changing in the x's and the y's by the same number, I could just write this ratio each time. Over here, I can't. So then we have to begin to ask ourselves, is there a unit rate? If I graph this, would it create a straight line? Will this be linear? Will it make a perfectly straight line? One way we have to figure this out is you are going to take these numbers and write them as a ratio. So I would have -9 over 3. how this y changed when that x changed, and I would get -3. I need to compare that to the next set. When I have a change in y of -6 and a change in x of +2, I simplify that, I get -3. Ooh, those look familiar, but I have one more to check. We're going to analyze our third set. When our y's change by -15 and the x's, our input, changed by +5, I still get -3. So our unit rate equals -3. It was constantly -3. If we were forced to graph this, we would get a straight line because of the constant rate, so it is linear. We'll keep talking about that part. Right now, we're just trying to figure out our constant rates. I'm going to challenge you to pause the video and try the next one all by yourself. I'm going to pause the video. I want you to work. I am going to first calculate how are my x's changing, and then I'm going to calculate how my y's are changing, and I will unpause the video so we can compare answers. So step 1, how did the x's change and how did the y's change? Just do that much. Pause the video, please. Thank you for pausing the video. I just spent a moment discovering how my inputs were changing compared to how my outputs were changing. I noticed here to here +2, +4, +5, excuse me, +8, +16, and +20. They aren't constant when I look at this yet, so we're going to need to investigate further like we did on the table next door. Excuse me, while I cough, I'm going to ask you to put it on pause, and you will look at each of these 3 relationships and compare them. Do we get the same rate of change? So I'm going to compare how the y's changed over how the x's changed. Again, let's try this one on our own, see how we do. Pause the video, please. Thank you for pausing the video. I appreciate you giving this a try by yourself. I just took how the y's changed in this and compared it to the x's. So I have +8 over +2 to get 4. I then compared the y's of change of 16 over x's of change 4 and got 4. Here I noticed we had a change of 20 in my y's, and I had a change of 5 in the x's. So once again, I got a +4. That means our unit rate equals 4. When we start graphing, it's positive, so our line will be going uphill, and it will be linear because our rates of change from one row to the next are all the same.